Welcome everyone. I see that more people are coming, and please let us fix some technical issues with presentation, and then we will start maybe in 2 or 3 minutes, okay? Okay, welcome everyone. Now the first presenter, Dan Vidanovic, will share his screen, and we start with our last day of training. Welcome everyone. As yesterday, all the questions are welcome in chat, and we will discuss them in questions and answers session. Okay, Dan, the floor is yours now.
Can you see my screen?
Yes, yes. If you activate subtitles here.
Yeah, so, ladies and gentlemen, dear colleagues, sorry for these technical issues. I'm going to give a presentation about practical case of validation and verification of the same real-time PCR method. And I want to show you what is the difference when you are validating some method and when you are verifying it on the real life example. I will show it. I will show you the validation of Tacman-based assays for specific detection and differentiation of wild-type and neatly vaccine strains of lumpy skin disease virus. This validation was done by my team and teams from several other laboratories, and you will see chronology of the validation. So, as you could hear yesterday, these are principles and method of validation of diagnostic assays for infectious diseases that are recommended by IAEA. And we followed each of these stages and steps in our way of validation. So, first thing is preliminary consideration. Definition and intention of purpose of the assay. So why did we decide to design a new real-time PCR assay for detection of wild-type and vaccine strains of lumpy skin disease virus? Because in 2016, when this disease occurred in the Balkan countries, and Serbia is one of those countries, we did not have any real-time PCR assay for differentiation of wild-type and vaccine strains. And we needed that because after outbreak occurred in region, the mass vaccination of cattle started, and we had to very fast identify if the animals are infected with wild-type strain or they are having reactions after vaccination. And those reactions were very similar to the clinical manifestation of actual disease. So in that time, only available assay was nested PCR described by Israeli colleagues, Mena Sherov and her colleagues, and we tried to do it in our lab, and we implemented it, but we were not happy with nested PCR because it's laborious and we wanted something faster and something less prone to contamination during the examination of samples. So in July, we started with designing our own real-time PCR assay, and in that time we did not have any experience in designing of prime.
It seems that there is a sound now. Can you talk, Diane, please?
Yes, we hear you. We hear you.
Okay. And did you hear me at all from the beginning of the presentation?
Only at the beginning.
How many slides?
Sorry?
Please.
Yeah, we start.
Yes, and please change the subtitle to French.
To French. Okay, let me just try to do that. Okay, let's see if it works. Yeah, okay. So I do not know how long did you were you listen to me, but I will repeat the few previous slides. As I said, I was going to tell you about practical example, what is needed to validate one essay, and also what is needed to verify the same essay that is already validated in some other laboratories. So just to see what is the difference, and difference is very big. It is about validation of TAC1-based assays for specific detection and differentiation of wild-type and needling vaccine strains of lumpy skin disease virus. So in previous days, you have opportunity to see this slide, which shows the principles and methods of validation of diagnostic assays for infectious diseases. And for our validation, we have used and we have followed every step of validation study. So let me just remind you that lumpy skin disease virus was the lumpy skin disease was disease that was until recently specific only for Africa. So in most of the European countries, there were no protocols for detection of it, but in 2016 and 2015, it came to European countries on Balkan Peninsula and also Turkey. And in that time, we had only few assays for specific detection of all Capripox viruses, but nothing for differentiation of wild-type strains and vaccine strains. And it was very important for us because in that time, mass vaccination started in Balkan countries, and we needed a test which could differentiate between vaccinal and wild type strains. And why is that? It was because some vaccines after inoculation were causing some symptoms in cattle which were very similar to symptoms from the natural infection of the animals. So we needed the assay to quickly differentiate it, is it vaccine or wild type strain. So we have designed in that time several different primers and probes in the same time, because we did not have time to design it by one. And we have purchased reagents, and what is very important, we obtained the reagents and the positive controls from IAEA, which first react to help the region in diagnostic needs. So it was very important for us because in our laboratories we did not have any of these strains to check our assays on specificity and sensitivity. So it took us 1 month to the assay for wild type strains. We were focused on this assay first, and later we were focused on designing of assay specific for needling-based vaccine strains. So as we heard in previous presentation, analytical specificity is determined by selected genetic sequences of organisms targeted by the assay. So assay can be designed to target a conserved genetic sequence that is common to several strains of some species or several species of a genus of some microorganisms. So this assay exhibits great inclusivity and making it a good candidate for screening test. And on the other hand, we can design a highly selective assay with analytical specificity for a single genetic sequence that is not known to be present in other organisms or strains of the targeted organism. Such assays exhibit great exclusivity and can be used as confirmatory assays or of high analytical specificity. So let me remind you that lumpy skin disease virus, together with sheeppox and goatpox virus, belong to genus Capripox viruses. And there are several very well established and validated assays that are specific for all Capripox viruses, and those assays are called pan-Capripox assays, and they are known by their first authors as Bowden, Balinsky, Hegeman, Sprigging assay, and so on. Actually, these four of them. And on the other hand, there are assays that can detect only goatpox or only sheeppox virus or only lumpy skin disease virus, but also there are assays that can differentiate wild type strain of lumpy skin disease virus from vaccine strain of lumpy skin disease virus. And first of these assays were developed in our laboratory together with colleagues from Friedrich Loeffler Institute, Dr. Ben Hoffman and his team. They developed their own assay, and we in the Veterinary Institute Kraljevo developed our own assays, but we have published it in one joint paper. So after that, there were designed several other DIVA assays for differentiation of wild type and vaccine strains, and colleagues from Greece and colleagues from Friedrich Loeffler Institute also developed other assays for this purpose. So, as I said in the beginning, we validated our assays on very small number of different strains and samples, and we called it specific only for Balkan strains of lumpy skin disease virus. But in later years, with cooperation with other laboratories and in cooperation with EU reference laboratory for Capripox viruses, Cienzano from Belgium, we have managed to include in our validation study totally 422 samples, from which 291 sample originating from naturally infected animals, experimentally infected animals, vaccinated animals, insects, and environment samples. Also, we have managed to collect 90 different Capripox viral strains, from which 42 lumpy skin disease virus, 31 sheeppox, and 16 goatpox strains. And also, we included 41 strain of other microorganisms that are related to Capripox viruses, or they are related to bovine species, and they can cause disease in bovine, to see the exclusivity of our assays. So on this slide, you can see that pan-Capripox virus assays can detect all Capripox virus strains that were included in our study. 90 strains of lumpy skin disease, sheeppox, and goatpox. So the analytical specificity of this assay is all Capripox viruses. Inclusivity is all Capripox viruses, and exclusivity all other microorganisms. And the assay that we developed that is specific only for wild type strains, as you can see on this slide, it detects only the green ones, and all of them are wild type strains. But do not detect, you see, exclusivity, nettling vaccine strains, sheeppox and goatpox viruses. So in our specificity study, our assay correctly identified 89 from 90 Capripox virus strains. It detected Kenyan strain, KSGP 0240, which is used as vaccine strain as a wild type strain. And there is explanation for that, because this strain is genetically very distant from nettling based vaccines, which are most common used as vaccines for lumpy skin disease virus, and that is why, and there are several papers describing these strains as inadequately attenuated, sorry. So that's why our assay detected it. But it is very important to know the limitations of the assay. So our assays could not be used in country that use this Kenyan vaccine strain for vaccination. It can be used only in countries that are using sheeppox vaccine strain or nettling-based lumpy skin viral strains for vaccination. And sorry. And here is on this slide you can see analytical specificity of our vaccine strain specific assay, and it's designed to be specific only to nettling-based vaccine strains, and it detected all 4 strains that we had in our collection, and did not detect any of wild type strain and any of sheep and goat pox strains. So results of specificity study is 90 from 90 strains. And this is exclusivity of both assay for a list of viral and bacterial diseases related to Capripox viruses of bovine species. So we tested it on BVD virus, blue tongue disease virus, foot and mouth disease, Schmallenberg, parapox, suipox, and so on and so on, and other bacteria that can be found in bovine species. So they were all negative with our assays. So analytical specificity. Analytical sensitivity we have determined by using a reference genome from European Union Reference Laboratory for Capripox viruses, Cinsano from Belgium, and they gave us quantified DNA from wild type strain, Bulgaria, 2016, and from nettling vaccine strain. So we just made serial dilutions of this quantified DNA and with 95% confidence in 20 replicate, we have determined that analytical sensitivity or limit of detection of wild type strain assay is 24 copies of genome per reaction. And analytical sensitivity of vaccine type strain specific assay was 12 copies of genome per reaction. You can see here are 19 positive and 1 negative sample in this dilution. And it was very, very hard to determine exact limit of detection, and we have repeated it many times. So in stage 2, we have tested diagnostic specificity, diagnostic sensitivity, cutoff determination, and also we used samples from reference material, reference animals or experimental animals, and we have a provisional recognition of our assay. So on this slide, I have shown the part of the determination of diagnostic sensitivity that was performed in our laboratory in Serbia, and the other part was performed in the EU reference laboratory in Cienzano in Belgium. Here you can see 163 naturally infected samples or samples from vaccinated animals. So we have determined the diagnostic sensitivity and diagnostic specificity of the assay. From these 163 samples, 150 we detected with our assay, and 3 more were detected with Bowden pan-capripox assay, which is slightly more sensitive than our assay. So by applying this formula, diagnostic sensitivity of our assays is 97.45%, and diagnostic specificity of our assay for wild type strains is 100%. And determination of diagnostic specificity and sensitivity for vaccine strain assay was 100% in both cases. So this assay is as sensitive as Bowden pan-capripox assay. So in stage 3, we have select collaborating laboratories, and we have very good cooperation with the Federal Research Center for Virology and Microbiology in Pokrov in Russia, and they have been tested our assays as a part of validation study for robustness, but also for sensitivity and specificity on their strains, because they have a lot of capripox viral strains that they could not send us in our country to test it, but they tested it in their laboratory. Also, laboratory of Faculty of Veterinary Medicine in Skopje, in North Macedonia. We have cooperation with them from the beginning of the validation study, and they have tested our assays in their institute, in their laboratory, on their instrument, with their reagents, on their own positive samples. So it showed that our assay is very robust and it can be applied in any laboratory. Also, Scientific Veterinary Institute in Novi Sad from Serbia, and of course Cienzano EU Reference Laboratory for Capripox viruses, and the Friedrich Leffler Institute from Germany. So you see, a lot of people were involved in validation of this study. And in stage 4, we did all of this, except we have analyzed an interpretation of results, deployment to other laboratories, assay modification. We have modified some primers in the second stage of validation, but I do not want to use much time explaining that. And only thing that is left is this international recognition by IAEA, but we will see what will happen. So, some numbers. In a validation study, 6 laboratories were included, totally 422 samples. And initial validation was finished in 3 months, but full validation, including validation in EU reference laboratory for capripox viruses, lasted more than 5 years. Well, it could be finished much sooner, but because of this COVID situation, the testing in EU reference laboratories were late more than 1 year. So this is a reason why it took so long. Normally, the validation study takes less time. So what is needed for the verification of real-time PCR assays? You need, of course, one laboratory, your laboratory. You need quantified genome of wild-type lumpy skin disease virus strains from reference laboratory, preferably. Quantified the genome of needling vaccine lumpy skin disease virus strains. You need 20 to 30 positive samples. If you have it naturally, it's great, but if you do not, then you can consider spiking of samples. You need 20 to 30 negative samples, and you need at least on each strains of capripox viruses, like sheeppox and goatpox, to include it in your specificity study. So what minimum parameters you should include? We were talking about these previous days. I do not want to take much more time, but as we said, analytical specificity, analytical sensitivity, repeatability, reproducibility, and uncertainty of measurement, which can be assessed through this data from repeatability, and after that, robustness monitoring, and of course, proficiency testing. So for the analytical sensitivity, you do not have to perform it with 95% confidence. You should only be good with testing 10-fold dilutions in triplicate, like in this slide you can see, and you just determine the limit of detection. Okay, I already told this. For analytical specificity, you need to have these sheep and goatpox virus strains, and also some other viral strains that you have in your bank of samples, just to confirm the exclusivity of the primers and probes. And you need to do repeatability and reproducibility as it was suggested in earlier presentation during this training course. So when you are doing a verification of some methods, please remember this presentation and remember what is all needed to validate it. So then you can realize that verification is not such a big deal, and it should be done very, very easily. That's all that I have to say for this training course. Thank you very much, and if you have any question, be free to ask.
Thank you, Dan. Thank you. I would like to ask participants to place questions in the chat. And while you do that, please, the next presentation now can be shared on the screen.
Good morning.
Good morning.
Share my screen. Hey, do you see?
Yes, it's okay. We have one question from Isheteki from Nigeria. You used 422 samples for the assay. What is the standard minimum numbers of samples for this assay? Dan, can you reply, or Igor?
I will read the his presentation.
Igor,
Yeah,
please.
yeah. I will answer it. There is no exact number saying how much samples you need to do, but at least not for infectious diseases. There are numbers in ISO standards for food testing, where it's calculated how many samples do you have to have in order to validate some study, and this number differs if you are validating your method against golden standard, or you are validate method that there is no golden standard to compare. So I do not know these numbers by heart, but they are numbers for food. But for infectious diseases, I think that they are not exact numbers, but as many as you can. It's the more the better.
Then thank you. And the second question from Mr. Taki is, I would like to know what environmental samples you used in your validation study and what other samples could be used.
Well, we were performing some examinations in the facilities where the infected animals were held. We were catching insects like flies, and also we were taking swabs from the feeding equipment or from the walls to see if there is a virus present on the facility after the depopulation of cattle that were in this facility. So yes, we used the swabs and we detected positive samples of environment on virus. So virus was all over the place.
Okay, thank you. Then I suggest now Igor. But Igor, could you please check your microphone because you're quite...
Sorry, Artem. Just before Igor start, I would like to attract the attention of the participants. There is a nice publication placed by Esaias, our colleague from Ethiopia, on the chat box of differentiation of 8 strains of pox viruses related to this presentation. So please, those who are interested in pox viruses, have a look at the publication there. Thank you.
Okay, is it now better, the sound?
Yes.
Yes, it's okay.
Okay, great. Thank you. So my today's talk would not be very long. It is not very difficult to understand. It's more technical. I would like to just present a structure, a template. At the end of all the work that you will done in the laboratory to verify a specific assay that it's fit for purpose, then you should put all these data and interpretation and evaluation in some kind of form, and that would be the verification report of this, and this would be the requirement of ISO standards during the accreditation process. So it is one of the documents that you should have to prove that that you have verified the performances of your assay as recommended prior to involve this assay in your routine testing. So just okay, so just to briefly present the structure of this report, what should contain. So first, you should describe the purpose of the assay that you are verifying. Then you should describe the scope and the description of the method itself. You should put the name of the operators involved in the verification study. You should include the connection with the quality management system that you have in place in your laboratory. So the specific procedure for verification of your methods, either serological or molecular methods. Then the description of the procedure of actually what you have done in your verification study should be explained and put the next. Then the evaluation of the analytical sensitivity and specificity, what tests you have performed to establish this or to evaluate actually. Then evaluation of the precision, definition of the acceptance criteria for all these parameters of these characteristics or performances of the essay. Then next, in the annex, you should, after you explain, you describe all these elements, then you should put the real data obtained during the study. And at the end, you have a conclusion and statement with which, if the essay passed the verification and proved to be fit for purpose, or that it's actually working as described by the original developer, then you state that this essay is fit for purpose in your laboratory for the intended use. And in the end, you have a signature that the responsible person, usually the head of the laboratory, should sign this verification report. So I'm going to just present, as I said, technically in practical an example. This was a draft version of a verification report. As you can see, the same we will be on the same virus, on the same topic as my colleague Dan previously explained his work for validation of a specific assay. So it was done in collaboration with IAEA, with one of the partner laboratories. So using their own available materials during the training course. So we, as I said, structure a verification report, which I think it might be helpful for the laboratories intending to accredit methods, whichever methods. So just to give some practical example of how it should be written. So as I said, first you should describe the purpose of your essay. So more or less it will be the same that you should put in your SOP when you write your SOP for this essay. Then of course the scope, and you can see here what is the scope, what are the genome targets that this assay is targeting, and then, as I said, you should write the name of the operators involved, 1, 2, 3, or how many people you have involved in the verification study. As I said, you should put the link to your quality assessment and quality control manual, your quality management system. So you state the procedure for verification, and then you describe the procedure, what you have done to verify these performances. So you have a list like you can. I hope you can read it from the screen. So we performed a standard curve analysis to evaluate the assay performance and demonstrate the determination of the limit of detection or the cutoff point. So we have evaluated the intra and inter-assay repeatability as a measurement of precision, intra and inter-operator repeatability for the provisional reproducibility of the test, and measurement of uncertainty so we can define the doubtful zone. Then you should describe the reference material you used in your study, and as you can see here in this particular study, there were 5 samples. If you can remember it from the previous presentation, this is the, let's say, some optimal number of samples needed to construct the repeatability sample panel samples. So we have 2 samples. The 2 first sample were actually in-house quality control material, so derived from the clinical sample. One was from the skin sample extract, and the second one extract from blood from animals, proven to be positive by other tests as well, and with the value, the estimated value done in comparison with the reference material. Then next 2 sample are low positive sample obtained within the proficiency test participation, and the third one as well, but it was a negative sample.
Igor, sorry for interrupting you. Could you please check subtitles if they are on, because we don't see any translation to French.
Yeah, yes, it's strange. When I started, there was translation. Let me see.
Igor,
Yeah,
it's because you're not in a slideshow. If you put in slideshow mode, it will translate.
okay, slideshow from the current slide. Okay, should I?
Yes, yes, please.
Okay,
It's okay.
should I go back and repeat or just continue?
Well, go back a little bit.
Okay. Okay. So, okay. As I mentioned, first in your verification report, you should state the purpose of the essay, more or less the thing that you need to put also in your SOP, the specific procedure or method that you want to verify. Then the scope of the method and the description of the method. As I said, you should mention what is the targeted size or which target genome you will be detected by this protocol. Then you should put the names of the technical person or the operators or the performance which were included in the verification study. Then you should mention the link to the quality assessment, quality control manual placed in your laboratory. So to state the procedure for verification. Then you should continue by explaining the procedure. So actually all the steps that you have performed during the verification study to assess all the characteristics of the assay that need to be verified. So as you can see here, as I said, in this study, verification study that we performed with the partner laboratory, we have performed standard curve analysis for evaluation of assays performances and determination of the limit of detection or the cutoff point. So for the measurement of precision, we perform intra and inter-assay repeatability as well as intra and inter-operator repeatability. And at the end, we performed the measurement of uncertainty to define the doubtful zone for this assay. For the reference material used in this study, as I said, we constructed this panel of samples, the reference material of 5 samples, 2 strong positive, 2 weak positive, and 1 negative sample. 2 strong positive sample were in-house quality control materials obtained in the partner laboratory from the clinically infected, actually naturally infected and confirmed lumpy skin diseased animals. One was the skin extract and another one that was the extract from blood. And the 3 external quality control materials were obtained within the proficiency testing panel provided by the EU reference laboratory. So 2 weak positive sample and 1 negative sample. For the verification, as I mentioned also in my previous talks, we focused on analytical sensitivity, and but of course this is why we included the negative sample. It's to, in a certain way, to a certain degree, let's say, verify the specificity of the assay as well in our laboratory. So for the sensitivity, you should perform 10-fold series of the in-house sample. This is the stated sample that you used for this. As we said previously, you should choose a strong positive sample so you can obtain at least 5 to 6 dilution steps, order of magnitude, in which you will obtain a positive result before you reach a negative result for the dilution steps. And for the determination of the limit of detection, how it was done. So after the initial 10-fold dilution steps, we performed in this study additional 2-fold dilution, so to more precisely define the limit of detection. The estimation of the measurement of uncertainty around the cutoff point was also performed by testing 10 replicates of the sample, which was stated here. You will see later on in the material. It was the sample one dilution step before the cutoff, let's say, before the last. So you use this sample and then perform two-fold dilutions in order to achieve more refined, let's say, cutoff point or the limit of detection. And as I said, the analytical specificity was assessed by testing these 12 replicates, because there were 2 operators involved, and the tests on this sample were performed on 2 separate days. So in total, we had 12 replicates of the negative sample deriving from the PT panel. So for the evaluation of the precision, you can see here you describe what you have performed, what I already discussed previously, what samples you used, what is their status, how many times you repeat them, and then you explain how you assess, actually how you will evaluate the intra-assay variation, inter-assay variation, and intra and inter-operator variation. Then you state, as we said, you put in the verification report what is the acceptance criteria. So which is the parameters that the test should achieve, what values. So for you to be able to say that this test performs as provided by the original developer. So for the we all spoke about this during the previous presentation. So you put the parameters of for the efficacy, the determination coefficient, and the slope of the PCR, and then you state that in the determination of the precision or evaluation of the precision of the test by performing the repeatability and reproducibility experiments, the coefficient of variation expressed in percentages should be lower than 5%. So if it's lower than 5%, then the test passed the verification study. And then you should mention if any, let's say, deviation from the established procedure within your working instruction in your quality manual, and of course if you perform everything according to your procedure, then no remarks there. And then after you describe all this in the annex, you should, as I said, put the actual data that you obtained during the study. As you can see here, first we have put the picture of the standard curve, and this is the data and the picture which which is obtained by the software of the machine, and this is just a picture of how the dilution curves standard curve looks like. So and then you just explain the results you obtain, and then you provide the table with the specific numbers. As you can see here, this is the sample, the strong sample, strong positive sample, and it was performed in 10-fold dilution steps until 10 to minus 6, and from the starting values and downwards, it with expressing the mean value for the CQ or CT, and then the coefficient of variation during these triplicates. You see all samples are done in triplicates. And here, as you can see in this table, we reach the dilution 10 to minus 5 from the original sample to be the last dilution in which we have all 3 sample positive. So the next dilution step already we don't have any positive signal. So this is, as we previously said in our presentation, it would be let's say you can use this as well, and you can say that 38.16, for example, because this is the mean value, would be your cutoff point, but you will see later on you should around this point determine the measurement of uncertainty to be able to put the doubtful zone as well for your final interpretation. Then you should include the data obtained by the machine for the efficacy of your PCR, the determination coefficient, and slope as well. And as you can see here on this graph, all the parameters are within the recommended values, so it passed the acceptance criteria. Then in the third table, you can see the results from the repeatability study. This is the very familiar picture and number for you because it was the same data set used 2 days ago for the repeatability study when we discussed about it. So it is already familiar. So you have here the formulas expressing the inter-operator and between operator variability, intra-assay variability, and then on the table number 4 you have the results for intermediate reproducibility by assessing the inter-operators coefficient of variation and inter-assay coefficient of variation. Of course, all this put into text. Here you explain that by evaluation of these results, you see that all these parameters, all these evaluations, all these actually coefficient of variations are lower than 5%, which give you show you that there is an excellent level of agreement between the results, both comparing one operator alone and between operators and between different days. Also, because all 12 replicates of the negative control sample return with negative results, you confirming the high analytical specificity of the assay. Then the next would be to define, as I said, a more fine definition of the limit of detection. And for this, we use. I can go back just a bit. Yeah, you see here I said you take one dilution step before the cutoff, let's say provisional cutoff, and you take this sample and then dilute and perform twofold dilution if you would like to do more precise, let's say, definition of the limit of detection. And as you can see here, twofold dilution steps were performed, and up until the third dilution, we have obtained all three replicates provided or give us positive results. In the fourth dilution step, you see that one of the replicates gave a negative result, and then this is the actually it is not acceptable. If you can remember, if you would like to state that we want to state our confidence level with 95%, for 100 sample, it would mean 95 out of 100 should be detected as positive. In using 20 samples, let's say, it would be 19 out of 20. If you use 10 samples, then you should have 9.5 actually, or all 10 samples should be positive. So in this case, we have 3 samples and 1 give us negative results. So we decide that this dilution, or this value actually 38.31 should be considered as a limit of detection of this assay. And then you use this sample and perform 10 replicates, 10 times, you test 10 times this sample, as you can see here, to determine the measurement uncertainty. And as you can see here, the measurement uncertainty for this at this point was 0.93 CT values. And you can define that according to this result, and a defined confidence interval. You should state the confidence interval. The doubtful zone would be 38.65 plus or minus 0.93. And then by this we set up the cutoff points for interpretation of the results. And according to this, so CQ value below 37.7, which is 38.65 minus 0.93, would be considered as positive result. So all results lower than this CQ. All the results with a CQ eventually higher than 39.6 would be regarded as some artificial amplification or non-specific amplification signal and should be regarded as negative. While the results lying between 37.7 and 39.6 should be declared as doubtful. Of course, it should be repeated again. And if the same results obtained, then you should provide the interpretation in your SOP, and this will depend on many factors. Most of them, the intended purpose, is it the confirmatory method, for which disease is it the, I think I mentioned this previously, whether or not you should report an outbreak of a new disease, emerging disease, and it will be also influenced by the clinical and epidemiological situation. So it's a bit complex, but with regard to the analytical and strictly the rules of interpretation according to your verification or validation criteria, this would be the cutoffs in this case that we find suitable for this assay in this specific laboratory. At the end, as I said, you have a conclusion and statement, usually written, of course, by the head of the laboratory, who, based on all the results and all the values obtained in this verification study, can say that this specific assay is fit for purpose and it's performing according to the expected performance for this assay set by the validation of the developer. And then at the end you state that it is suitable for use for a screening, so you defined for which purpose. So it's a screening method for detection of the presence of capripox virus genome in skin and blood and lyophilized sample. So this is also, as we mentioned previously, important to state because we use this kind of sample as a reference material. If you would have even more, maybe swabs or other type of material you should use, just to be sure that during the verification, let's say phased verification study, you can confirm the suitability of your assay for different matrices, that it will give you and provide confident and stable results in all these matrices. Of course, then at the end you have signature and your date, the date when you have finished this report. This is all, as I said, again, requirements from the ISO 17025 standard. I hope it was not boring and it was helpful. It was some kind of template. It is still in the draft version. Probably it will be changed during the next period. But I hope it will. Some of you will find it maybe useful for their future use. So this is all for me for today. Thank you very much for your attention. And of course, if there are any questions, I'm happy to answer.
Thank you very much. Thank you, Igor. We have a couple of questions before we go to break. Would you please consider giving us the notes so that we could reread and work? Okay, I think this will be done later on.
Yeah, this will be provided, yes, with the materials.
Then we have a question from Sierra Leone. How do you proceed with verification in a situation where you suspect a disease agent that has not been isolated in your location, or you are just interested in checking if there are possible cases of particular infections that has not been reported in your area, since you require in-house reference material that you don't have for verification?
Yes, I will go back a bit to the slide.
A bit long question, but I think the question.
Yes, I understand. Yes, yeah. I get it. Yeah, I just explained here that in this particular study that we use the sample that were available in the laboratory in the time, and we use these in-house samples, which is not, let's say, perfect, maybe because I'm not sure. I'm at the point. I'm not sure of their actually the true value, but we had to use it because the laboratory did not possess any other external quality control material, so they did not have in their possession some strong positive sample, let's say, involved in the maybe proficiency panel. So they have only these low positive samples, but regardless, we use those samples as external quality reference material, and we use these in-house quality reference materials to be used as a strong positive controls. Of course, if you have, if you would like to verify or implement some assay for which you don't have the disease in your country, or you don't know if you have the disease, and you don't have in your possession any clinical specimens or other type of material from the disease, of course you should you must have obtained somehow an external quality controls. So either from proficiency testing or from some reference center, maybe the reference laboratory or some international OIE reference laboratory, for example. So you must have some let's say reference material very well quantified or certified, and then it is desirable if you have a strong positive one, so you can use this, as we mentioned the previous days, to spike this material into the appropriate matrix, and you can provide and you can produce actually your secondary standards or in-house standard, which you can then compare by the with the original, and you can use them as a low positive or medium positive samples. However, if you would like to verify or to go through this, you must have some reference material in your possession.
Thank you for this reply, Igor. The next question is from Botswana. It takes time to get results from other labs. So can we publish a newly developed and validated assay in journals without results from other labs?
I will leave this question to my colleague Dan if he is okay with it.
Yes. Well, you can try to publish, and the reviewers of the paper will assess if you performed enough examination to call it validation. So you could see in previous days what is needed for validation. If you have performed every of these steps, then you can publish it, of course, but if you are not, then you just not called it validation. You call it development of new assay for this and that, and then you state what performance of the assay you examined, and that is it.
If I can add, well, it can be also preliminary validation. In urgent cases, sometimes there is no time to do that, so you have to do only preliminary validation for newly emerging disease, and then it has to be accepted for the certain period of time. Then, in the meantime, you are doing the full validation.
Yes.
Okay, thank you. Next question from Dr. Teki from Nigeria. The importance of cellular immune response in capripox virus infection. My question is, how is the cellular immune response assayed? May someone take this question? How to assay cellular immune response?
Yeah, I can just say that there are assays for assessing the cellular immune response, but I am not familiar with them, so I cannot further comment. But yes, there are.
Well, I could probably add that you measure it with flow cytometry, but the technique is quite complex and expensive. That's why, actually, for capripox viruses, of course, immune response is difficult to estimate. One question from Turkey. When you calculate the limit of detection, you use 3 triplicates. Is it enough? Is it representable for 95% confidence? What if one of 10 replicates was negative?
Yes, as I said, it would be perfect to perform 20 replication, because for 20 replicates, you could have, let's say, one of these samples providing you a negative result. So if you have 19 out of 20 detected as positive, give you a positive signal, this would be 95% confidence that this is the endpoint or the cutoff or the limit of detection, actually. But if you have a limited resources, either samples or reagents, however, then if you use 10, like I presented, so you would have theoretically 9.5. You should have, out of 10, you should have 9.5 positive. And in theory, this is impossible, of course. So if you use 10 replicates, then you must have all 10 replicates positive to obtain 95% or a little bit above of confidence. If you have one negative out of 10, this is already 90% confidence. So if you would like to express that your confidence level around the limit of detection is 90%, then you can do it and you can accept this. But it's generally 95% confidence is used as a confidence level. So for that, you need all 10 replicates giving you a positive result.
Thank you. And the next is question or comment, I don't know, from Hafsa Madani. How many set of primer have tried so far? Maybe you mentioned it and I didn't catch.
I don't know if you think this is the question to me or maybe to Dan. How many sets of primers?
It's probably for me,
Yeah.
because I said that for wild type specific assay, we have 2 sets of primers, and first set was not specific enough. So the second turned out very good. But for vaccine strain, we did it in 4th time only. So we have 3 unsuccessful primers and probe that were not so specific, and only when we designed 4th time we got very good specificity and also sensitivity. So it was not that easy how may it look.
Okay, thank you. From Dr. Binta, how do you deal with matrix effect when the target analyte is to be detected in different matrices, for example, animal feeds?
Yes, this is, yeah, as I said, this is the part of this. First, it's a part of validation study. So during the development and optimization of the assay, and first with starting with the development, you state for which purpose your assay should be used. So this includes also the range of matrices in which this assay should give you or perform equally good. So if you do not have the specific matrix in the validation report, then you should then do the validation for this matrix. But if there are data for that, then in your verification, during your verification in your laboratory, just to prove or to state that you can use this assay to test this kind of matrices, you should include in the verification study representative sample, reference sample from this matrix. So As I mentioned here, we have only used the blood skin sample and the lyophilized sample, so we can say that in our verification study using this type of material, these matrices, we can say that the assay performs as prescribed, let's say, or defined, and we can say that it is fit for purpose in our laboratory for this type of matrices. For any additional matrices which we should perform separate or additional verification.
Okay, thank you, Igor. Thank you. I don't see any more questions for now, but before we go to the break, Michel Warnaud would like to take the floor, but if not, then I would like to ask all of you to enable your cameras because we would like to take a group picture, and I will allow now all cameras. And please, Igor, could you please stop sharing screen, and then everyone enable cameras, and then I would like to ask Federico if he's... Federico, are you here?
Hi, Artem. Yes.
Yes, so you better know how to deal with this,
Yes.
to have all them on one screen.
We are a lot of us, so it would be difficult to get us all in the same picture. So I will try to take several. Maybe if people can leave their cameras on for a couple of minutes.
Yes,
That's
please
okay.
keep on the cameras.
Good morning or good afternoon, everyone. Just to check whether you can see the screen and if you can hear me.
Yes, everything okay.
Excellent, excellent. I have to go back to the first slide, excuse me. Yeah, the last presentation during this training course will be easy. It's Friday, but I think it will be interesting for you. We will talk about external quality control or proficiency testing. I think that all of you, yes?
Sorry, after your presentation, I will have a short presentation on application of the test in the field. So, sorry. So it will not be kind of official presentation, but it will be just a notification of the participants. Thank you.
Okay, thank you. So, as I said, I believe that all of you, if not most of you, already have participated in proficiency testing or any kind of external quality control, whether you are accredited or not, and whether you have verified your methods or not. But just in case, for those that might not have participated, what is the PT concept? So the reference or advanced laboratory will prepare 6 samples, and they will not be labeled. There will be positive, negative samples, weak positive, strong positive, and this is called panel. And enough number of these panels is produced, and then it is sent to regional or national laboratories, and they have a certain period of time. It's usually 1 month. They have to test all the samples. They have to record results for each of the samples, and they have to send back their results to the reference laboratory. Then the reference laboratory will prepare a report on performance or proficiency. That's why we call it proficiency testing, to the laboratories, so they will see how good are they in their performance or their proficiency. Going back to yesterday's presentation, we said there are 3 lines of control samples to supplement quality control and quality assurance process. First line control samples are those that you include in every test. Laboratory comparisons other than proficiency testing. So what does it mean? Here we have an explanation. Proficiency testing providers that must meet the requirement of another ISO standard, it's ISO 17043, are considered to be competent. So if the proficiency testing is done by someone who is accredited for that norm or conducts interlaboratory testing according to ISO 17043 standard, then it is proficiency testing. Everything else is interlaboratory comparison testing, including also proficiency. It doesn't mean that other interlaboratory comparison testings are bad or something that is not desired. On contrary, you will see in next slides by the end of my presentation. You have seen this. It is OIE manual chapter 116 for validation. So this is assay development and validation pathways. The last but not the least is validation status retention. The same is for your verification. You want to keep your verification status retention. It means that you have to monitor and maintain by verification criteria, and you will use proficiency testing to do that. Another OIE chapter, it is quality management in veterinary testing laboratories. For accreditation, for those laboratories that have to be that are going to be accredited or accredited, they have to demonstrate proficiency in the test methods used, for example, by participation in proficiency tests on a regular basis. You will see periodically, regularly, etc. But what does it mean regular basis? No one gives an exact exact period of time when you have to take participation. Some standards, they foresee at least once in 5 years. I understand that, but my suggestion would be try to participate once a year if it is possible. Even more, if there is an opportunity, do not miss any chance to participate even more frequent in these either PT or interlaboratory comparison tests. Of course, you have to balance between the costs and the benefits. Some proficiency testing are free of charge and are sent from reference laboratories for a particular disease, but also you can find proficiency testing that you have to pay. You can go to Google and just click EQA, External Quality Assessment, and you will see offers where you can participate, but you have to pay that. But even if participation is free of charge, if organized by, for example, IAEA or some OIE reference laboratory, you will have costs that are related to testing of the samples. Usually, at least some of the samples are retested to be sure in your result. So definitely any PT or interlaboratory comparison testing has costs, but also has benefits for due to participation. So what are the benefits of participating in PT programs? First of all, you confirm your competent performance. Also, you can identify problems that are related to testing or measurement. You can compare different methods and procedures that you apply in your laboratory by the PT panel, and you will definitely improve performance because you will see where you can make improvement in your laboratory testing. Also, it can be used for educating your laboratory staff. You know that continuous education is very important. But also you can compare operator capabilities. If you have two technicians and you want to see which one is more reliable, are both of them reliable or none of them, then you can give the PT panel to one and to the other operator and then to compare the results. And now I'm going back to a question of Temitope from the chat. How do you proceed with verification in a situation where you suspect a disease agent that has not been isolated in your location, or you are just interested in checking if there are possible cases of particular infection that has not been reported in your area since you require in-house reference material that you don't have for the verification. Here we are. One of the very important benefits of participation in proficiency tests is generating reference materials, because you will not spend all amount of the sample. Usually you spend just less than half, and you will have the rest that you can use as a reference material in your laboratory. And that's a very important point why you also have to participate, whether you are requested by your authorities or someone else. And finally, it's satisfying regulators and accreditation bodies. So if you are accredited, you know that one of the things that assessor will ask you is definitely, have you participated in the PT for the particular disease, and please give me the result to see what is your performance. So don't even think about accreditation if you didn't take part in a PT program. So what is the purpose of the PT panel? The first and the most important is to assign a score. It's pass or fail to each of participating laboratory. That's why when we send our results, we are very keen and impatient to see the final report, to see whether we have passed or we failed the proficiency test. But also to quantitatively assess the performance of individual laboratories, including the identification of real and potential sources of error. Maybe your results is within the acceptable range, but at the very margin. So the organizer will warn you, he will or she will say, well, you are very close to cutoff and you value, but you should have a result of, for example, medium sample in meaning of how strong it is. Then to provide a quantitative measure of repeatability within laboratories and reproducibility between laboratories to compare with each other. This is also very important to achieve fairness in laboratory evaluation in terms of giving positive or negative status to individual samples. By participation, you show your proficiency to say reliably whether some sample is really positive or negative. And finally, to ensure that the test system is sufficiently robust to be used for this intended purpose. This is also in validation, if you remember a few slides ago. But also, if you intend to introduce additional testing in your laboratory, then you can use samples from the PT panel to see whether the system is, the new test method is robust in your conditions to give reliable result. What is usual structure of the PT panel? The minimum is 5 samples, and they should comprise at least one sample which will produce an equivocal negative result. One sample should be unequivocally weak positive, and one sample should be strong positive. The two remaining samples, they can be selected from any of the combinations above, but it doesn't mean that the panel should have only 5 samples. Additional samples may be included. For example, EU reference laboratory for avian influenza and Newcastle disease in panel for molecular tests usually have 15 samples, and each sample is tested for multiple targets. Well, not all laboratories, particularly local laboratories within a country, have access to proficiency tests or inter-laboratory comparison tests. So advanced regional laboratories like national laboratories, they are encouraged to organize inter-laboratory comparison testing. In some countries, they are obliged, national reference laboratories are obliged to organize comparison testing for other laboratories within the country. So having 15 years of experience, and particularly the first PT that I have organized, here are my experiences. So if you are going to organize interlaboratory comparison testing, you should bear in mind, particularly for non-advanced labs. First of all, the panel should not be too difficult, because it can be discouraging for laboratories that are not very experienced and at the low level. And I'll tell you an example of my first, excuse me, interlaboratory comparison testing. It was in 2007. We have prepared 3 panels for avian influenza and Newcastle disease, molecular panel, serum panel, and antigen detection panel. So we have invited different laboratories, and 16 laboratories have participated. Most of them were very advanced laboratories. For example, there were 2 from Great Britain, 1 from Italy, 1 from Sweden, 1 from Austria, then from Canada, Hungary, 2 from Poland, etc. So when selecting samples, I didn't want to leave an impression of a superficial laboratory and providing very easy samples. So I have chosen very difficult samples, not by the quantity, but by the selection of strains. And at that moment, I thought it will be very good to make a proficiency panel good. At the end, out of 16 laboratories, only 3 laboratories had a perfect score of 100%. 13 of them could not identify all of the samples provided. Well, the 3 laboratories, they were very happy, and they said, this is excellent panel. It was quite challenging to us. Excellent job done. But on the other hand, I was thinking that the purpose was not accomplished, because all those advanced laboratories, they should recognize in everyday routine work all the samples in proficiency panel, and these could not do that. So what I have done, I just have shown that I can make them very difficult task, but they could not compare their real proficiency. So when I look back now, I see that it was really a disaster making such proficiency panel, but any mistake is an opportunity to learn what to do in the future. Okay, the samples also should not be too easy. Do not put only strong positive samples. Also take care that the panel should mimic local and regional epidemiological situation. It means don't put inside some strains that are really exotic to your country and similar. Regarding the quantity, also for these tests for smaller laboratories, try to mimic quantity of the analyte that you should expect in the field. So try as much as possible to mimic what they will have in the field. And then anonymity is a must. If you are not sure that you can retain anonymity, do not organize proficiency testing. Then writing instructions that are sent by the panels, or you email them, and reports, that they must be clear and easy to understand. Tell them what and how they have to test. If the samples are freeze-dried, how to reconstitute in what volume, etc., etc. Everything must be clear, comprehensive, and easy to understand. And finally, quality and uniformity of the samples is extremely important. So rather have fewer samples, but with good quality, than to try to put a lot of samples and you are not sure whether they are uniform and whether they are of a good quality. And finally, the PT samples should meet criteria in general, and they should be possibly derived from a single animal. This is not always possible, particularly if small animals are in question. Sometimes from chicken you cannot draw enough blood to make a big enough panel to send to all participants. Then, of course, you should pool your samples, but try to make it from if the animals are in the same phase of infection. So don't take one animal and draw blood 3-4 times and pool. Rather have 5 animals and draw blood at the same time. Also, the samples should be undiluted. Of course, impossible. Maybe you will have only strong samples, but if you dilute, you can dilute in a negative sample to retain the same matrix. And of course, what you would not expect in your PD sample, also do not send to other laboratories. So the samples should not be lipemic, hemolyzed or contaminated. Avoid freezing and thawing, especially repeatedly done frozen and thawing. And what is also important, the samples should be innocuous. It means they are inactivated, they are not capable of causing infections. This is particularly important if you are sending your sample to another country, because you can spread disease by a very good intention by providing them inter-laboratory comparison test samples. Also, when you prepare volume for each participant, keep in mind to give them sufficient amount for repetition at least once of the test in the question. Again, weak positive should ensure that the sample does not give equivocal result. So sometimes if you prepare weak positive result in 50%, it will be positive, in 50% it will be negative. So by taking that, keeping that in mind, half of the laboratories that will give negative result, they might be proficient, but by chance they gave negative results. So keep in mind that weak positive should not be at the very edge of the cutoff value. And this is also very important. All aliquots of a given sample must be derived from a single batch. So every participant must have sample from the same batch. Do not mix batches because you will not be able to compare proficiency of the laboratories. And finally, the test samples should be allocated unique in the identity codes. So all must be clearly marked, and each participant must know what sample is what, and later on in your report you will recall a number of the samples when giving explanation of the result. So that would be everything about this presentation, and if you have any questions, I will be happy to answer. Thank you.
Thank you very much. And yes, we have some questions. I think, shall I read them now? Ivancha, what do you think? Well, we have.
Okay, Artem, sorry.
Sorry.
Just before you read the question, I want to thank Vlado on excellent presentation and thank him for reminding me of the proficiency testing that he was organized in 2007 because my laboratory was one of the participants and we did not perform very well on, and it was my first proficiency testing. Yeah, so thank you for reminding me for that.
My apologies.
Okay.
Okay, we have a few questions for you. According to your so far knowledge of information, is there any intention for an harmonized approach by ISO organization as regards the procedures of validation, verification, measurement, uncertainty for ELISA and or PCR diagnostic techniques?
I don't know to whom the question is addressed, but I don't have any information on that question.
I think that actually the question or the issue about of the harmonization or the recommendation are already set up within the OIE manual and the recommendation, and ISO only requires that you can prove that in which way you perform this, and that to prove to acceptable level that if you say that your assay performs as it should be, that you support it with the evidence. I'm not sure that ISO specifically prescribe a procedure how to do it. Just because in your SOPs, in your verification reports or other documents related to the ISO, you should include the reference that you use to do that. So I'm not sure that it will go in that way.
Thank you, Igor. One more question from Dr. Teki,
Sorry.
Nigeria. Yes,
Sorry,
Ivancho.
Artem, I just wanted to complement to this question.
Yes.
You know, all we were talking about the whole week, including participation at the ring trials or proficiency tests, is part of the process of harmonization. So it's a process. It's not prescribed explicitly in ISO. If you want to say that your method is harmonized, this is what you need to do. But the whole verification and validation process is about harmonization. So especially the participation in the proficiency tests and the use of standard reference materials are tools for harmonization. And finally, the reviews of the results of the proficiency test, what Vladimir mentioned, the importance of the identity anonymous submission of the results and presentation. So during the interpretation of the results, even if you have a common meeting with all participants, the results will be anonymized. So you will see number there, laboratory number 7 performed this, laboratory number 11 from this. Then you can see your lab operating with other laboratories and determine the gaps and determine the targets to improve for the next proficiency test. So overall, the process of harmonization covers all these activities that we mentioned during this week. Thank you.
Thank you, Ivancho. So the question from Dr. Teki, Nigeria. Do you think it would be necessary to obtain permission from the sender laboratory before using PT or ILTC samples as reference materials? What about use of results from such samples for publication? Would it require permission?
Well, yes. Usually the sender of the samples will notify you that these samples are exclusively for the PT and that they are not used for further distribution or selling or everything else. So, but if you use it as your reference material for your own purposes, no one will take it as something bad or wrong. But for publication, you should definitely inform the organizer of the PT and not to publish before his agreement or permission.
Thank you, Vladimir. Second question from the same trainee. Since the panel of samples should be inactivated, then isolation test cannot be carried out on the samples. Is it right?
Yeah, that's a very good question. For example, for viruses, I know that there was some initiative in the EU that we will receive live influenza and live Newcastle disease virus in proficiency test, but no one could approve that. But on the other hand, for some other microorganisms like bacteria, if you work in laboratory with salmonella in poultry, for example, your proficiency test will contain live bacteria. But these are a special kind, let's say, special kind of proficiency test. But if we are talking about viruses in general, it is not acceptable. Particularly if the virus is not present in your country and you have to perform virus isolation. It's very risky.
Okay, then.
If I may, I would just like
Yes.
to add, to complement to this answer from Vladimir. Yeah, if you would require PT with the diagnostic technique, which is virus isolation, then you will receive a different sets of samples. And as Vlado mentioned, depending on the disease or the pathogen in question, there are specific requirements with regards to the biocontainment level of the laboratory. So if it's +3 biological material, then you should have permission first to receive such sample and to provide that you can operate with this kind of sample. So in this case, you are usually asked by the PT providers whether or not you will request infectious or non-infectious panel. So if you request and if you provide evidence that you can handle, that you are approved to handle with this kind of material, then you will receive non-inactivated panel.
Thank you, Igor. Now, question from Jennifer Maravilla from Philippines. How do PT provider assess results submitted by participant, especially in case of molecular testing using PCR, where there is a wide range of CT values submitted in a specific test? Do they consider the possibility of degradation of PT samples during transit, like in warm countries?
Well, regarding interpretation in the ISO standard dealing with proficiency tests, there is a lot of text explaining what all criteria and values should be reported in the report. So I think it's too complicated to go into details right now. Regarding degradation of the samples, well, the samples must be constitute in the way that they will not degrade. So either they should be freeze-dried, either they should be in a cold chain, or any other preservative will be added to the sample. Particularly for molecular tests, the same adjuvant is given to inactivate and to conserve the sample. If you are organizing a proficiency test or inter-laboratory comparison test, before sending samples out, you have to do all quality tests. So while you keep your samples, for example, in a freezer, a certain one panel or two panels you will keep at room temperature, and the other one you will keep in incubator at 37 or maybe 40 degrees centigrade over a period of time, and after that you will test. And then you see whether the sample is robust enough to maintain without degradation until it will reach the participating laboratory. But also a cold chain during sending the samples is also an option.
Thank you, Vladimir.
If I may just once again complement or add additional things with regards to this, because the implication of the proficiency test results, it's really high. So in case the participating laboratory fails the proficiency test, it will mean that it might lose the accreditation. And that's why usually, because with which what Polado said, it's that the reference laboratory prior to sending is testing the samples for stability and all other parameters. But then usually they require notification upon when you receive the samples. So they just to see to measure the time from sending, from dispatch to receive, to when you receive it in your laboratory, and then usually they ask just from you to say in what condition, if everything was if the samples are in good condition or maybe defrost or something else. So they should take this into account during evaluation of your results. And of course, if something is not as it should, then follow-up should be that they will send additional maybe samples to see if the variation or unsatisfactory results were maybe the issue was the transport of the samples.
Thank you for this comment. The next question is from Akbir from Lomtago. I have a question for the retention maximum period of aliquot or sample in laboratory. So what is the retention maximum period for aliquot or sample?
Okay, maybe I will take this. We mentioned during this this training course that you should, especially your reference materials and internal controls, you should prepare them in as much as possible bigger quantities, and then you should prepare aliquots of these samples. And these aliquots, the volume of these aliquots will depend on the frequency of use in your laboratory. So if you have frequent use and you test many samples, then this aliquot can be of a bigger volume. But if you use the test rarely, then you should prepare smaller volume of these aliquots. So just to avoid, if possible, this frequent or multiple freeze and thaw cycles. So it is usually recommended not more than 3, but okay, 4 and 5. Then you should let's say estimate your frequency of use, and then calibrate the volume of the aliquots so you can spend this controls in maybe 3 to 5 runs. And if stored properly, let's say on -20, it should be valid for a long period of time. But as we mentioned during this course, continuous use and implementation of these materials in your routine testing and following the results will indicate not only the problem in the system, I mean with maybe the instruments, the reagents, but we also indicate the status of the control. So if you see degradation in the value of some control in some aliquot, then you should test another one, and in this way you can assess, is it the problem in the specific aliquot, maybe because the degradation of the target of the DNA or RNA, or it's maybe the problem is somewhere else in your system. So it can be used for a long period of time.
Okay. Next question from our colleague from Nigeria, Dr. Tiki again. If the agent in the PT sample is endemic in the recipient country, must the panel of PT samples be inactivated before shipment?
Well, if the panel is not intended for virus isolation, then it definitely should be inactivated, because proficiency testing is organized for many countries. So if the organizer sends samples to 30 countries, it is unlikely that in all 30 countries some disease will be endemic. And all the samples must be the same from the same batch. They should be either inactivated or live. So in such cases, they should be inactivated either if, for example, your country is endemic for that disease.
Okay, thank you. A question from our colleague Shima Al-Faki. If we participate in a PT perform calibrate the equipment we use in the assay and we gain a good result. Is it not accepted for accreditation? Well, question probably is not very clear, but try to comment, please.
If we participate in PT before calibrate the equipment, we use an assay and we gain a good result, is it not accepted? No, if your result is good, then it should be accepted. It means that your uncalibrated machine gave good results in proficiency testing, and I don't see why the results should not be acceptable. But it doesn't mean that you don't have to calibrate. You definitely must calibrate your equipment.
Sorry,
Okay, thank you.
sorry, Artem, just to complement, I
Yes.
agree with what Vladimir says, but calibration, verification actually, and calibration of the equipment is a requirement by ISO. So if you issue results generated on uncalibrated equipment, it's not in compliance with ISO, because if you have implemented ISO 17025, it is one of the tasks of the laboratory staff to verify regularly the equipment and not allowed testing on non-verified and calibrated equipment. So it's a process, it's a workflow. So yes, I know that many laboratories do not calibrate the equipment in regular intervals. This equipment can be fully operational and fully okay. Nobody says that, but as a requirement of ISO, for you to ensure that the process is okay, you have to calibrate. It's part of the tasks of the accredited laboratory. Thank you.
Thank you, Ivancha. Now we have one request to share procedure of inactivation. Please let me know if you can do that. And then we have a question from Dr. Abiola from Sierra Leone. Do you need once and for all verification for an assay using the same equipment, or there is need for periodic repeated verification procedure?
Well, first about inactivation process, it is not a unique process for all kinds of samples. You will differently inactivate sera, you will differently inactivate clinical samples, etc. Also depends from causative agent to causative agent. So there is no unique procedure to do that. You have to refer to a particular matrix and a virus or bacteria, whatever you want. And the next question is, do you need once and for all verification for an assay using the same equipment, or there is need for periodic repeat? Well, I would suggest the periodically repeat verification. It's not once you have verified in your laboratory and that's it. Periodically you should perform verification, and as it was mentioned in the introductory lecture, also whenever there is any change, if there is a new technician, new operator, if new equipment came, etc. So it is a continued process to do verifications.
Okay, one more question from Jennifer Maravilla. During PT, we are required to provide the extraction and PCR methods employed by our laboratory. I have observed using different extraction kits or methods, even using same PCR kit, gave different results. CT 3, 5 CT values difference. But I chose the result with lower CTs. I was wondering if PT provider would give a better impression to labs with lower CT results.
Well, it is important for the CT you achieved to state what isolation method you have used. So it can be compared with other laboratories and methods in other laboratories. So what is your benefit? It's that you will see in your laboratory on the reference samples whether your method A or method B gives a better result.
Thank you. Thank you for reply. I don't see more questions, and now Ivancha wanted to show a slide and give a comment.
Okay, I wanted to give few comments and a few slides only to let's say kind of finalize this, summarize this course. You know, first important thing is we are trying to organize face-to-face courses if the COVID situation allows. So this course will be, let's say, extended and continued with practical face-to-face training courses in each of the IAEA regions, with real consumables, real diagnostic kits, real forms, and real calculations, you know, so that the diagnosticians can touch the lab and touch the bench and feel the results and discuss together with the experts. These courses are planned after the generic SOP is published and reviewed by these several reference laboratories, and lecturers at these training courses will be also invited people from the reference laboratories, so that we keep the thing in a high level and harmonized level. So this is about the continuation of these training courses. Most probably we will have 4 such regional training courses, 1 for each region. The other thing is about the interlaboratory comparison proficiency tests and standard reference materials. We already mentioned, sorry, I need to share the screen to have the French translation, yeah? I hope it will work. So my second comment is about the interlaboratory tests and standard reference materials. We are already working on the establishment of continuous access of all our counterpart laboratories to proficiency tests and standard reference materials. Right now, in these days and these weeks, we contact vast majority of the reference laboratories, if not all of them, and we hope that within few weeks to few months we will have agreement with them for continuous supply of standard reference materials and continuous access for all our counterpart labs to interlaboratory trials. The cost of these materials and interlaboratory trials will be covered by our program, so the partner laboratories will not pay, it will be free of charge for them. A brief explanation. We were supplying laboratories in the past almost through every project, but the requests were, I would say, sporadic, once in 2 years, once in 3 years, once a year, and so on, and they were very fragmented. So fragmented means this month laboratory in country 1 asks us for 3 controls for brucella and 2 controls for foot and mouth disease, and then nothing, silence. And in 6 months, another laboratory asks us again, I need 5 controls for brucella and 3 controls for foot and mouth disease. And these requests are very demanding for the reference labs to produce in such a way. So what we are trying now with this intensive contact that I just mentioned is to organize an annual supply through our ongoing project. So the annual supply will be, we will ask all our partners, can you please subscribe? What do you need for this year? You subscribe, you tell us these controls and these proficiency tests. We subscribe you, so in end of February, we close the subscription, so no more subscriptions for that year. And we order all together for all laboratories, materials plus subscription for the proficiency test. And every year, we plan to repeat this process. So if some laboratory misses the subscription this year, they will be able to continue next year. So I think that's a good idea. This was my second comment on the last presentation or last discussions. And the third comment is about the local production of calibrated secondary standard reference materials. You saw that one of the topic of the last days was local production of calibrated materials, and this procedure will be integrated in the SOP for verification. And this, I think, is a very, very important note, because local production of secondary reference material makes it easier for the diagnostician to calibrate their test, and makes it much cheaper for those who support or permanently pay for standard reference materials produced by the reference laboratories. What you can receive from the reference laboratories is a few vials of 0.5 milliliter or 1 milliliter of a positive control, weak positive, strong positive, whatsoever. But what you can produce in your own lab from your own animals is liters of sera or liters of positive PCR control if you have a virus isolation facility. So we are talking about different dimensions of quantities, different levels of quantities. So supply of standard reference materials goes 1, 2, 3, 4 vials. Local production of calibrated liters. So it's much, much more advantageous for the local laboratories. So these are my three main comments for your information. So what I wanted just to try to quickly go through is my presentation from some years ago. I find it very interesting. Why? Because now it summarizes all the verification procedures. Actually, we assume that all the verification procedures are finalized. Our test has passed the evaluation, so it is, yes, we can use this test. And we know the diagnostic performances of the test. This is what we as diagnosticians are expected to deliver to the veterinary authority. And then the epidemiologist at the veterinary authority is the one who should now organize the control measures, vaccinations, or whatsoever based on the testing strategy in the field. So I have few notes. So this presentation is borderline. Few notes on the test performances and few notes on how these tests, what should be considered for the diagnostician and for the veterinary authority, for the epidemiological context of the test. We are talking about the test, but we never mentioned, the animal. So what we see here is our flock of 200 sheep. And all of them are white. And in order to investigate is there a disease or not, we need to test these animals, okay? And what is the purpose of the test? The purpose of the test is to show us what is the status of these animals. So if we assume that 50% of this is very trivial, yeah? Very easy going, yeah, easy numbers. If we assume that 50-50 are sick and healthy, we have 100 healthy sheep, these are the green ones, and 100 diseased sheep. But so this will be how the flock will look like if we can detect the disease by eyes without the test. But we need a test. We cannot see them. They're all white like this, yeah? So the point is, if we now transfer this status of the sheep in a table, we have 100 with 100 disease healthy, but we do not see the test in this context. And the test is what? The test is our marker. The test is this square. I don't know if you see my mouse, which should highlight the sheep in green and highlight them in red if they're sick. So the test will tell us, of course, yeah, this is green, this is good, yeah, this is healthy, and this is bad, this is red, so it's sick. And if we have a perfect test, we will have, of course, all diseased detected as positive, so this is this A box here. None of the diseased will be presented by the test as negative. And the same applies for the healthy. 100 of the healthy will be detected as negative. 0 of the healthy will be presented as positive by the test. So this is the easy scenario with the perfect test. And if we go to the Gaussian distribution curves that were presented several times during the past few days, we will have one Gaussian curve of the negative animals. So this will be here again. This is a idealistic drawing of the Gaussian curve. It will never look like this in the practice. But to make the things more clear, so we have one distribution of the results of our tests in the negative population, another distribution in the positive population, and we have the cutoff in the position where the two Gaussian curves do not touch each other. And as Vladimir mentioned, the Gaussian curve has some rules already established by the statisticians. Yeah, one standard deviation covers 68%, which means almost 16% are at the left side out of the standard deviation. Another 16% is on the right side. And if we take 2 standard deviation, it is 2% to 25% left and right. And if we take 3 standard deviation, it is 0.1% out of this range. So if we apply now this thing to our test and our overlapping or separation of the Gaussian curves, Gaussian distribution curves of our animal populations, and if we overlap them exactly at plus minus 1 standard deviation, we will have proportional number of false positives and false negatives, yeah? And in this case, with 1 standard deviation, we said that around 15.9, 16% of the animals are out of the range of 1 standard deviation. So in this kind of overlap of the test, we will have 84% sensitivity and specificity, both the same, with almost 16% false negatives and false positives. If we have a test that performs an overlap of two standard deviations, so only one standard deviation overlap, will have a test with 97.5, 95 sensitivity and specificity respectively. Okay, so it's easy. I think it's clear what the overlap and what the probability gives us. But once we establish this, the overlapping range of our assay, what we can do, we can move the cutoff left and right, which will result with the change of the sensitivity and specificity of the test respectively. And we said, yes, a few days ago, that this determination of the performance of the test depends on the purpose of the use of the test. But we must be very much aware with our statistics and with our verification, what are the statistical performances of our test. So if we go this easy way of presentation of the goods, one standard deviation overlap, and we add the cutoff one here, the one at the left side, right arrow, we will have for this test 100% sensitivity, so none of the positives will be shown by the test as negative, but we will have 50% specificity, which means that half of the negative animals will be presented as positive. So this is this area here. If we move the cutoff now to another position toward the center, yeah, so this is the cutoff 2, we will have 99.9% sensitivity and 84.10% specificity. So moving the cutoff from position 1 to position 2 will result with 0.1% loss in the sensitivity and 34% increase in the specificity. So you see, the dynamic is different when moving from one to the other position. We move it further to position 3, we have for both 97.75, 97.75. And we move further to position 4, we are losing the sensitivity and we are gaining on specificity. So if we plot this table here on a graph, so one graph is the upper right corner, the blue line here. It's only two columns, sensitivity and specificity, dependent on the movement of the cutoff. We will get this curve. Or if we plot them against the value of the cutoff, we will have the second graph. We will see how what is the interrelation between the sensitivity and the specificity of the test. Of course, this is more a kind of importance for the application of the test in the field. And this correlation here you can find in the literature, like receiver operating characteristics. I think someone mentioned, but I didn't see a more detailed kind of explanation. And this is how do we apply the test, you know. So if we have unknown situation in the region or a country or a continent, and we want to see, is there a disease, and if yes, where is the disease located, in which areas or sub-areas or municipalities, then it is reasonable to go with the high specificity and lower sensitivity. So with the test like this one here, 99.9% specificity, 84% sensitivity. Why? Because almost none of the negatives will be shown as positive, so we will not have false positive results, and we will be able to detect 3/4 of the positive of the sick animals. So we will not have false positives, but we will have 3/4 of positives detected. So we will be able to say, yes, out of 2, 3 infected, we will capture 1, and we will say, yes, in this village, on this farm, I have a positive animal. But if the epidemiologist actually wants to have eradication of the disease, so no presence of positive animal in the field, they will need to consider extremely high sensitivity and be aware of the specificity, which means I will be able to detect 100% of the sick animals. However, 16% of the healthy animals will be presented by my test as positive. So I may slaughter these animals for nothing. This is just a loss because of the test performance. That's why the test performance is extremely important. So coming back to our experimental flock with 50-50 sick and healthy animals, we can see, okay, if I have my test with given diagnostic performances, how will the test operate on my flock, on this one that we are watching right now? So I selected just by, for example, a test with the diagnostic sensitivity of 90% and diagnostic specificity of 95%. So if we repeat now the situation in the table, our test will be able to diagnose correctly 90 out of 100 positives. So we have 100 positives. We said we have 100 sick. So 90 will be detected, but 10 of them, the test will not be able to detect. And for the healthy animals, 95 of them will be detected as healthy, but 5 will be declared by the test as sick. So they will probably go in the slaughterhouse or in the hole. So in this scenario, the predictive values, the thing that the expert mentioned during the beginning, will be 95% for positive and 90% for negative in such a situation. So what does it mean for our flock? For our flock, it means that 5 of the healthy animals will be labeled with the red color. So we will say, oh, these are sick, but actually they are false positive. And 10 of the healthy animals, of the sick animals, sorry, will be identified by the test as healthy. What is the consequence? For the false positives, for these ones, they will be economic loss probably. They will be slaughtered or killed. But these ones are very dangerous because the test will not recognize them. They will stay on the field and they will infect other animals after the campaign is finalized. So we have to consider that. But once we have determined the diagnostic performances of the test in the laboratory, we do not know usually the situation in the field. So we have only white sheep in front of our eyes. And if we go with our test from the experiment, this is what the test will recognize for us. So the test will tell us, hey, here you have 95 positive and 105 healthy, which is not true because at the beginning we said we have 100 with 100. So the prevalence based on our test will not be 50%, but it will be 47.5. So the test is actually cheating us in some way. But how much it is cheating, we do not know because we do not know the real prevalence. However, if we know the diagnostic performances of the test, there is an easy formula to calculate based on the diagnostic specificity sensitivity what is the real prevalence of the disease in the flock, and that's if based on this formula, the formula will tell us yes, with this test with the 90% sensitivity specificity 95%, you replace here the values and you have what equivalent to 50% prevalence. So we say, yeah, out of this 200, if I have 50%, they're 100 with 100, okay? And then we go proportionally. If there is 100 disease, my test is 90% sensitive. I have 90 plus 10. So 10 are fake negative. And the same applies for the specificity. 5 are fake positive. So this is our clarification of the situation using a test with known performances. And coming back to the predictive values, if we manage to suppress the disease, again, very, very trivial situation, just to see how the test operates on the field. Imagine we have prevalence of 90% with our test of sensitivity 90% and specificity 95%. So if 90% of the animals are sick, the predicted value will be 99.4% for positive animals, for sick animals, and 51.4 very low probability when we say it is a negative, that the animal is really negative. But if we suppress the disease, we eradicate, we remove the sick animals, and we achieve 50% prevalence, exactly the same test used in the best conditions, in the best way, best quality control, will give us this result. So we have 94% positive predictive value, so it is decreasing compared to the previous scenario, but the negative predictive value is increasing a lot. And if we have 10% prevalence, if we further suppress the disease, again, the positive predictive values is decreasing further, and the negative predictive value is increasing further. So if we put this on a graph, on the left side will be our test with 90% sensitivity, 95 specificity. And in the right side is a improved test with, let's say, 99% sensitivity, specificity. An example, the correlation correlation between the predictive values at different disease prevalence of the same test with exactly the same performance. So that's about this application of the test in the field. So I can share this presentation with you. This is just for your information and consideration that even we do perfect results in the field, there will be sources of uncertainty in the results, especially when we convert the result from the spectrophotometer with the status of the animals. This is sick and this is not sick. We still have considerations on the uncertainty of the test because of its performance.
Contact for Sanger sequencing support. This is from Morian BTU. Ivancho?
Tim,
Yes.
I don't know if Ivancho has an issue, but it's Ivancho to whom you have to address yourself in case of needs for the sequencing services.
Here is my email address. Do you see my email address here?
Yes, yes, yes. Okay, so take your notes.
Okay.
We have a couple of questions more. Is it possible for your organization to organize reference animal feed for detection of animal protein as part of BSC control? This is from Dr. Binta.
Ha. The monitoring of BSC is drastically reduced to my knowledge. We are talking about bovine spongiform encephalopathy, if I'm not wrong
Yes,
with this
yeah.
abbreviation. So, and as far as I know, the checkups are either cancelled or minimal for special categories of cattle. Reference material, theoretically, yes, it is possible to order, but in the last maybe 5 years, no one has ever asked from any of our counterparts, and we have plenty of counterparts. We have 100 plus counterparts per project cycle. So nobody has ever asked. Whereas for rabies or foot and mouth or lumpy skin or PPR, people are asking quite frequently.
Okay, then the question from Mr. Hafsa Madani. So far as I understand, we can require reference material and proficiency testing from IAEA. Is it so?
Yes, that is true, but we will inform all of you once we establish the workflow with the reference laboratories. Hafsa knows that we are circulating the emails to all our counterparts for important issues, and we are informing, so we will inform you once the workflow is established. We will send a circulatory email to all, and you will be able to order once a year at the beginning of the year for that year, not for the next 20 years, yeah? So once a year for that year, and we will supply you all. Sorry, one more thing, Hafsa, assuming that you are participating in a national or regional project. If you are not counterpart in any of them, we won't be supplied to ship. Won't be able to supply just blank because someone orders, you know. So because someone has to pay, so the projects are paying these reference materials to maintain the level of quality control in the labs.
Thank you, Ivancha. I don't see any more questions in the chat. Maybe we are ready for closing remarks now.
Maybe Michelle can give you a word. So I have nothing to add. I was really happy to see such interest in this training course, and I said I hope to see you face to face in the near future. So thanks very much, and maybe Michelle can say a few closing remarks.
Thanks, Ivancho. I was trying to share a slide. I'm not sure it's functioning. But anyway, it's not a big deal. In fact, yes. Let me just would like to thank first, of course, our two lecturers, Dr. Vladimir Savic and Dr. Igor Zadzovsky. Thank you very much for this training course over the last 5 days. This is the first training course we organized at this scale, at least, under the Zodiac initiative. You know that the Zodiac initiative was launched by our Director General Grossi in June 2020. It was announced, at least at the time. It was launched officially a few months later. This is a major project in which we are initiating a lot of activities. This is the first one, and hopefully only the first one. So we will have many other ones that are coming. both virtually as this training course, of course, because of the particular situations we are facing in relations with the COVID-19 restrictions for travel. But this is, of course, the virtual trainings we have and we will have will also be followed by face-to-face trainings. So very soon we will have another training, virtual training on IVETNet. Probably most of you heard about this this platform.
Sorry, Michel, can you put the presentation open to show the French translation?
You don't see the slide?
I see the slide, but it's not on the full screen.
Ah.
And you don't have translation, so just please.
And I don't see
the slideshow. Slideshow and
let me see. Is it better that way? Eventually?
No, it's not on slideshow. In order to see the subtitle, you need to put on slideshow.
Yes, thank you. I know, but this is what I was repeating to everybody since the beginning of the week. But I have an issue of launching it in a slideshow. That's so no. Okay, I don't want to take too long. Sorry for this technical issue, but I hope I will make a short translation in French afterwards. So what I was saying, yes, that soon we will have a training course on IVETNet. This is the platform that was developed by our colleague Ivan Chernaletoski in the animal health production section. Probably most of you know about that platform. But if you don't, I really invite you to attend this course. This is a tool that will be very useful for you. We had many requests for information about references, SOPs, methodologies, and so on. Many of these information are, for instance, available on IVETNet. So I really encourage you to attend this training course that is coming very soon, probably, and the third or the fourth week of March. You will be informed in any case. We have your contact details. You will be informed. We also have planned also a virtual training course on sequencing services. Several of you were also interested. We will have that soon. Both virtual and at a later stage with the face-to-face meetings, hands-on meetings. This training course will also be implemented, organized face-to-face for a hands-on version in the coming months, most probably. And in fact, after we will have established the generic SOP that was mentioned several times during this week. You know that what was demonstrated to you this week will be the object of a document established by a group of experts, including the ones you saw during this week. And that will be the basis of this course that we will be providing in some times. We are also preparing documents that will also be the basis for other training courses on biorisk management. And just for your information, next week we have a major expert meeting on this topic, and this will be also translated in a few months in related training courses. Okay, I think this is it. I would like, of course, to thank my colleagues who were part of the organization of this training, both in the moderation and in the logistic support. You have seen them if you didn't see them on the pictures, at least you saw their name regularly. We had, of course, Ivan Chonaletoski, Artem Metlin, and Dejan Vidanovic. Dejan, who was also a lecturer, he took care of the presentation this morning when we unfortunately had this small technical issue. But it's also, maybe you know that we have a second training course that we are organizing in the afternoon for other regions in the world, and in which Dejan is one of the lecturers indeed. So of course, thanks very much to Dr. Igor and Dr. Vladimir. And we have also a few colleagues who took care of the many challenging situation, the logistic situation here. We have Alexandra Lefort, Federico Verli. There was also Ahmad Mazraoui, who unfortunately is not here today. And our colleagues, of course, who took care of the implementation for the recruitment of the experts, my colleague Hannah and Susie. And then I would like to thank you all the participants, because this was, I think, a very good training. We had a lot of participation of enthusiasm from your sides. I would like also to thank you for your encouraging remarks. We had a bunch of remarks from you in the chat and outside of the chat. So it's very rewarding for us also to know that it's useful, that you are actually taking advantage of what is provided as information in the course. So thank you very much for that. So for English-speaking participants, I just add as well that as you were informed several times during the week, the recording of the meeting of the training, will be available soon, including the presentations that were provided by the experts all along the week, and they will be available through the Zodiac platform that will be inaugurated soon. You will be informed. I will inform each one of you by email at the moment this will be available. So thank you very much, and looking forward to seeing you very soon for other events on Zodiac. Bye-bye.
Michel, sorry,
Yes, my dear.
few more words. Just good that you mentioned IVETNet and biosafety courses, biorisk management courses. So, you know, IVETNet is a huge support for integration and organizing ISO 17025. So all the details you need for starting from personnel records, competence records, quality control, methodology, equipment checkup, infrastructure checkup, environmental conditions, everything is there. So this training is aimed to give you knowledge how to upload the data on IVETNet, so it's online platform, keep all the relevant data, and when the auditor comes for accreditation, you just press the button, and we support you in this process together with these technical methodologies, standard reference material, and so on. On the biosafety, what is important for you, very, very important, please consider designated personnel for the biorisk, biosafety management training courses, because we plan to organize wherever possible training courses with certification. So the participants at the training course 1, for example, we will have soon calibration of biosafety cabinets, will come back home with a certificate that they are authorized and competent to calibrate biosafety cabinets, and so on. So majority of the courses will be with certification. So what we need people from your biorisk management team to attend these training courses and contribute back your laboratories in building the biorisk management system. Thank you, and sorry for this interruption.
It's okay. Thank you very much. Bye-bye.
All the best. Bye bye to everyone.
Bye-bye.
Bye bye to everyone.
Bye
Bye-bye.
from our side as well.
Thank you.
Thank you all.
Bye.